Well, good afternoon, everyone. Thank you for joining us today for an interesting presentation on important high-capacity backhaul considerations and solutions. I'm John Sallantana with the Strategic Marketing team at Tesco. I will be your moderator for today's webinar featuring Bridgewave Communications, who will be discussing simplifying high-capacity backhaul with microwave and millimeter wave solutions. Before we get started, a few housekeeping items. This webinar is scheduled for 1 hour from 2 to 3 p.m. Eastern Time today, Wednesday, August 27th, 2014. The presentation is being recorded for replay. A link to the replay will be posted on the Bridgewave portal page on Tesco.com. All lines will be on mute throughout the presentation. You may pose a question at any time using the chat feature. We will answer as many questions at the end of the presentation as time permits. For those questions not answered, we will post a link to the answers on the Bridgewave portal page on Tesco.com. Look for an email advising when those links are live. So let's get started. Powerful mobile devices and smartphones are driving demands for high-speed connections at the edge of wireless networks. In turn, these connections are creating heavy traffic loads that must be hauled from the edge of the network back into the core, where this traffic is routed either to the internet or within a private network. What is the best way to implement backhaul facilities to handle high-capacity traffic in different network applications? Public and private network operators have alternatives that must be considered when making that decision. Considerations include initial and growth capacity, reliability, time to install, and first costs and ongoing operating costs. And that's what we want to cover today. Our presenter is Joe Schrammel, Vice President, Solutions Marketing for Bridgewave Communications. Joe has worked in product management and marketing wireless solutions at Bridgewave for the past 7 years. He has 29 years experience in working in wireless networks in a variety of roles. I have been in telecom for over 25 years and have developed a lot of knowledge and expertise in public network infrastructure. Tesco Technologies is a leading wireless equipment distributor in North America, representing over 300 manufacturers and more than 25,000 products. We are partnered with industry-leading companies such as Bridgewave to deliver reliable, cost-effective wireless solutions at the lowest total cost of ownership. Bridgewave Communications is a leading supplier of millimeter wave radio systems with over 20,000 such systems deployed in 60 countries for carriers, service providers, government and private networks. Bridgewave's expanded product portfolio now includes high-capacity and gigabit microwave solutions. Bridgewave is delivering backhaul solutions that enable significantly reduced total cost of ownership compared to leased fiber or copper line alternatives. So now I'll turn the presentation over to Joe.
All right. Thank you, John. And good morning, and good afternoon, and good evening, wherever you're tuning in from. And thank you for taking time out of your day to listen to us on the webinar. Hopefully we'll get some good information for you on gigabit wireless. And what we'll do is we'll kind of walk through some of the challenges facing either enterprise or service provider operators today. We'll go through some use cases of how these gigabit wireless links help solve some of these issues. And then kind of present the product portfolio here. So what I'd like to do is go ahead and start talking about the challenges on the networks today. And kind of broke this down into two different types of networks, service provider networks and enterprise networks. Now, enterprise private networks, looking at those networks today, there's an increasing demand for higher performance connections supporting newer business applications. Everybody's moving applications to the cloud. You get your Oracle, SAP, Salesforce, and remote offices where people are just logging into the web, needing higher speed connections and higher backbone connections for those new business applications here. We're also seeing expansion of the workforce, and that's really prevalent here in Silicon Valley where Bridgewave is located, where you've got a number of companies expanding the workforce, moving into new buildings, and trying to rapidly deploy network services to those workers who are not on the corporate LAN, making those network connections on the remote LAN just as fast and just as reliable as if somebody was connected there at the next cubicle over here. We're also looking at IT departments with distributed servers, looking to see how we can get connectivity to those distributed servers, so things like backups and server communications can be done more efficiently, more effectively. And then finally, we're seeing too with using unlicensed solutions, in the 2.4 and the 5.8, the ISM band or the uni bands. They work great today. What about tomorrow? You've also got a lot of employees bringing their own devices into the office now, and so whether it's a smartphone or a tablet or being able to have that connectivity using their own devices, causing interference or security concerns with the unlicensed spectrum for backhaul. On the service provider side, we've all heard about the explosion of 4G LTE networks over the last few years, and there was the iPhone phenomena where networks just couldn't keep up with the traffic. I think the carriers have done a great job trying to corral that phenomena and get their backhaul networks into shape, but there's still a number of places where the backhaul is the bottleneck, and using your smartphone to watch video, it sometimes works, sometimes it's choppy, but we see that there's the backhaul bottlenecks are still being solved, and the topic for a whole different webinar would be on small cells, but that's really not the focus of this particular webinar here. On the service provider side, with multi-tenant units or multi-dwelling units, how can you generate differentiated service revenues in looking at the triple play services, voice, video, and data, and having that backhaul capacity to be able to do that cost effectively. And we'll talk about some examples of that here. Aging backbone doesn't provide enough bandwidth. As we all know, what worked just a few years ago, bringing a couple of T1s to a building or E1s outside the U.S. just doesn't work anymore here. And bringing new services to those buildings. I've got customers that I want to get service to, but it's going to take me weeks or months to get lease lines or fiber to that building. How can I go ahead and get services generated on my network? And we'll talk about that here in just a little bit. And then lowering your costs to maintain a competitive edge, certainly important in today's business world. So, it works today. You bring an unlicensed solution in today, bring a couple of T1s in today, but does it work tomorrow? So let me go ahead and move on to, this GigE wireless in the enterprise here. And what we're seeing in a couple of different verticals, and I just kind of highlighted them here for you, in the medical space, where we're seeing the shift to medical records, EMR, electronic medical records, where your MRIs, your X-rays, your patient records are all being digitized and stored on a centralized server somewhere. And you get doctors or even nurses, patients wanting access to those anytime, anywhere. Being able to just call it up on a tablet and seeing what the image of your knee looks like after the MRI. Being able to have those capabilities not only in the hospital, but in the outlying outpatient clinics and medical office buildings that may be associated with that hospital in a particular area. In the public safety and video surveillance space, we're seeing a move now with the cities and municipalities, the agencies looking to do video surveillance as a way of helping to add more feet on the street for the officers patrolling the areas here. We've got a nice case study on this to present to you a little bit later on in the presentation here. And then campus connectivity, again with universities, even K through 12 schools, looking for more ways to bring the internet into the classroom, or being able to have those higher backbone facilities for large research files. At the same time, with students bringing their own devices on campus, the universities and schools adding Wi-Fi access points and Wi-Fi hotspots, being able to get connectivity from those Wi-Fi access points back to to a central internet connection or central POP on the school is where we're seeing applications for GigE wireless in the enterprise. On the network side, the service provider side, or the carrier side, this is a chart that just continues to amaze me every year. I read the Cisco VNI report, and just the forecast of traffic going over the internet it continues to expand and expand and expand. And just a couple of tidbits here for you on the right-hand side. The global mobile traffic is increasing at a 61% compound annual growth rate over the next 5 to 6 years. And in mobile traffic in 2013 was 18 times the size of the total internet traffic in 2000. So it's 13 years we've increased it almost 20 times. And just from last year to this year, from 2012 to 2013, this report was actually published in February of this year. Traffic increased 81% year over year from last year here. Mobile traffic mobile video traffic exceeded 50% for the first time, and then it's amazing to think almost half a billion devices were added in just 2013 alone. With that, smartphones, 21% of the total market for mobile devices, but those smartphones generated 88% of the network traffic here. So at the end of the day, is your network ready, or is on the enterprise side or on the service provider side? And that's kind of where the foundation for the GigE wireless comes in here. And take a look at lease costs for these network connections here. And this kind of sets up where we're going with doing some comparisons on using GigE wireless. And just surveyed some service providers online here, and got some numbers for T1, somewhere around $300 a month to lease a T1. 10 megabit service, about $800 a month. DS3, 45 megabit service, about $1,500 a month. And you can see, 100 megabit fast Ethernet service, OC3, 155 megabit frame service there, so $2,500 and $3,700 a month. And then finally going to GigE leased fiber, about $5,000 a month. And this is the monthly fee. Doesn't include any of the startup costs or and at the same time with some of these fees here, you're almost always going to be required to sign a long-term agreement, 24-month, 36-month agreement to be able to achieve these fees here. So, fiber for GigE connectivity, I think we all, if we all had the opportunity to use fiber, we would. Even at Bridgewave, we understand fiber is the killer app for providing GigE connectivity between point A and point B. But it's a reliable choice, and it gives you that high capacity, future-proof backhaul that you need, as well as it is secure. But it comes at a cost in implementation here, whether you're going to go ahead and trench fiber yourself, securing rights of way, getting the permits, being able to cross city streets or dig up sidewalks, things like that. And it's expensive. It's very expensive to trench fiber, depending on if you're doing it in the city, or even the rural areas here. I've heard anywhere from a couple 10,000 in rural areas to 100,000 plus per mile in city areas here. And again, really depending on where you are. And then at the same time, it takes a while to get those fiber circuits in. If you've got to put them in yourself, you've got to trench them, or you go to the service provider and they've got to facilitate them. They've got to go ahead and get them installed and do all the testing on that. So it does take some time to do that. So it's not very easy to just get it going when you need it there. And it's something that really has to be planned long in advance, and it's vulnerable too. Here's just an example here on the lower right here of a construction crew severing a black fiber line that wasn't on anybody's map. You can imagine the disruptions to that once that happens there. Okay, so why GigE wireless? It's less expensive than high-speed lease lines, and I'll kind of go over some examples of that as we go on into the presentation here. It's certainly faster time to install. If you need a connection in less than 30 days, GigE Wireless is certainly able to do that for you. Whereas if you were going to a fiber connection, it might be months out. And extra time if you're a service provider. That's revenue that you can't generate if you're an enterprise an enterprise entity. You want to get your business running quickly there. It's an alternative technology for primary and backup links. So if you do have a fiber in place, and I'll show you an example of this in the use cases portion of the presentation. But if you do have fiber in place and you want a peace of mind that you've got a secure backup in case the fiber breaks, and we'll go over an example of that. And that future-proof connectivity, again, these are full duplex, full gigabit Ethernet wireless links, so 1,000 megabits each way, give you that future-proof connectivity you need for today and tomorrow. And you've got control of your network. So if you're not relying on somebody else to come out and service your network or fix your problem, you've got control over the maintenance of the network. And if I need to move things around, if I need to add things, these GigE wireless links gives you that ability to do that. Okay. So a couple examples here. We talked about enterprises establishing off-site connections. I've got the scenario here where I've got a main building and a new off-site connection about half a mile away. I need about 10 megabits of service to connect the workers in that new building. At $800 a month with the startup cost of about $1,000, I'm looking at about just under $30,000 to go ahead and provide that 10 megabit connection between the 2 points. So we'll come back to this slide here. Just remember for this first example here, it'll take about $30,000 to do this, and I'll show you how we can do this much more effectively with GigE Wireless here in a minute. In the second example here, we've got a hospital that's putting in a new outpatient clinic. We need a high-speed connection between the hospital and the outpatient clinic and through the data center where all the MRIs, the EMRs are stored, and we're going to be providing PAC service through these connections here. We also need HIPAA compliance because of the HIPAA laws in the medical industry here. But we go to lease fiber about $5,000 a month, and because we're going to sign a long-term lease, they'll service providers nicely waive the installation and the startup costs here. But over a 5-year lease contract, so 60 months at $5,000 a month, it's about $300,000 per line, and I'm going to need multiple lines to be able to get that fiber from the data center where all these EMRs are stored out to the hospital or to the outpatient clinic. And if I'm looking for network resiliency and redundancy, GigE Wireless can also help me do that by providing a way to close the loop here. So if I were to do this with fiber, we're looking at about 900K, maybe slightly less if because we're leasing multiple fibers, and we'll probably get a discount from the service provider. But at the end of the day, we're still looking at a significant amount of money to be able to put these fiber connections in between these 3 facilities here. So I'd like to just kind of look at the economics of GigE Wireless relative to leasing fiber here. So in the first case where we saw the remote building needing high-speed connection, that 10 megabit connection, we looked at it and we saw that it was about just under 30K to be able to do that. Well, we can take a GigE wireless link and maybe a 60 gigahertz radio with the installation, the materials, and add on some extra warranties for that, and still get significantly lower than that 30K price point for that 3-year lease, and not only provide connectivity, but provide over 100 times the speed of that 10 megabit connection that we were doing here. So we could actually put GigE in between the 2 buildings here and be able to provide all the voice, the data, the video, the internet, intranet, all the business applications very easily over that GigE circuit for less than leasing that 10 megabit circuit from the service provider. In the case of the hospital here, where we're doing multiple years on a fiber lease, this chart here kind of shows how GigE Wireless can provide a much lower TCO relative to a 3-year fiber lease, where you can see if we're doing a longer-term fiber lease or multiple fibers, this GigE Wireless connection or connections certainly provide much lower TCO relative to leasing fiber here. And in fact, many of our customers have said they've been able to break even in months compared to leasing GigE circuits here. Okay, so I'd like to go ahead and go over some of the wireless applications that we see our customers doing today. The first one here in the 4G LTE backhaul space. So a few years ago, we had supplied a number of 80 gigahertz radios to Clearwire. You can see some of the images here on the left-hand side. In the New York City area, there's probably about about 800 to 900 links licensed already. You kind of see the little red lines within the map there. And quite a few of these connections now have actually grown in capacity from 1 gigabit to 2 gigabit by adding on a second link here. So when Clearwire is building out their initial WiMAX, now migrating to LTE network, they built it up using Bridgewave gigabit Ethernet links to provide that high capacity backhaul that they would need for these 4G LTE connections. Okay. On the service provider side, we've got another service provider here, XO Communications, looking for high capacity transport to expand their networks. And these networks, these network connections are network connections that are built off of a fiber ring. So being able to take and establish new customers off of an existing fiber ring, you could do it through fiber, or you could go ahead and use gigabit wireless to get to those new customers. And as I mentioned earlier, how can you generate revenues more quickly and get revenues going from that new customer? You can take 3 to 6 months to put in fiber, or you can take under 30 days and get the GigE Wireless and get the high capacity backbone for those customers done very quickly here. Built for this particular application, 3 of our FlexPort 80 links and delivered just over 3.6 gigabits per second to the remote location here. And it's also provided a level of redundancy into the network for XO. An application here, interesting one, Stanford University, just up the road from Bridgewave. They have a biological preserve where they do a lot of research out in just west of the campus in the foothills there. The existing connection was a Wi-Fi 802.11n connection that was pretty unreliable, went down a lot, and at the same time, a lot of researchers were using their own Wi-Fi devices and causing interference, self-interference to the backbone connection. So came to us and said, you know, we need a more reliable, higher speed connection out to the Jasper Ridge Biological Preserve, and we worked through an integrator here in the Bay Area to provide 2 of our GE80 radios, or GE80X with the 2-foot antennas here. Really what it's done with for the university is it's provided them a future-proof network backbone connection for Jasper Ridge Biological Preserve, but it's also instilled confidence in the IT managers, and that they didn't have to worry about the network going down, and they're quite happy with the performance of the system. The biggest thing is because the biological preserve because the area was a biological preserve, they could not use fiber out there. They could not trench fiber or dig up the preserve to get fiber out to the classroom out in the preserve there. So wireless is really the only way to go for Stanford University. On the healthcare side, the Franciscan healthcare system needed some way to reestablish, to quickly reestablish connectivity between the hospital and an outpatient clinic. The existing connection wasn't very reliable, and it went down quite a bit. They needed that a high-speed connection protection because they were doing EMRs and PACs as well as HIPAA compliance for the patient records there. So what they got with Bridgewave, they built up a ring of about 4 or 5 links around the hospital and the surrounding campus. They get that fiber equivalent performance of a full gigabit Ethernet. Backbone was deployed relatively quickly, and over a 5-year period, the IT manager projected over $500,000 savings relative to using leased fiber. Excuse me. On the government and municipality side, here's an application that we still get quite a number of requests for information on. A number of years ago, the Dallas Police Department went to go implement video surveillance cameras in the downtown in the downtown Dallas area, especially in the tourist area, West End area of downtown Dallas. And what they wanted to do is they wanted to put in video surveillance cameras, do wireless backbone, but they didn't want to use the 4.9 gigahertz public safety band for the backbone because they were using that 4.9 frequency for the access points to the vehicles and to the first responders there. So we built a ring around the city of downtown Dallas, connected it to the police command center over by the convention center with GE 60 radios, and now there's a network of cameras. I believe there's over 200 cameras now within the network, being able to look at all sorts of areas there, and have that extra feet on the street for the police department. The other thing that to mention here is that these GE 60 radios have very low latency on them, so it allows the officers in the command center to actually do pan, tilt, and zoom on the cameras and get real-time response because of the low latency on these radios here. Okay. On the enterprise side, this is just an example here. Hershey Entertainment Resorts there in Pennsylvania, looking to have connectivity to a number of facilities within the theme park. They needed that high-speed connection for video surveillance, for voice over IP, data, and even point-of-sale type of applications here. So we built a network using our GE60 radios, given that virtual fiber connectivity and a complete ROI in less than 2 years with these GE60 radios here. A couple of years ago, I think many on the East Coast remember Hurricane Sandy came through. After the hurricane came through, we had a number of inquiries from folks wanting to implement some kind of disaster recovery plan. And Cornell University being one of them here, they already had fiber on the network. Many of the campus buildings, many of the buildings on campus were already served with fiber. But they wanted a backup, and that backup, they wanted to have that same performance on the backup that they would on the fiber, but they didn't want to go to fiber because they had already had that in the ground. So having alternate fiber routes is certainly one way to do redundancy, but having a different media, fiber and wireless, gives them that network resiliency and network backup, and much more cost effectively than putting in the fiber alternate fiber routes between the buildings on campus here. Okay, I think the last one I have for you is really interesting one. It's every February, many of you probably tune in to watch the Oscars on TV, and over the last couple of years, we've been working with the network integrator for the Academy of Motion Picture Arts and Sciences to provide backbone connectivity to the broadcast center at the Kodak Theater, or it's now got a new name. It doesn't come to me off the top of my head. But in the past, what they used to do was they actually used to put the production pieces on video and have a courier, and this was done about a mile away at a post-production facility, put the video clips on film, have somebody actually ride a bike through traffic, get it over to the theater where it was uploaded into the broadcast booth and then sent out over the air. what we were able to do was establish an 80 gigahertz link between the post-production facility and the codec theater there, as you see in the picture, and enable the editors at the post-production facility to spend more time editing, doing a little bit finer quality control. So the engineers at the MPAA were able to get the files much more efficiently than having to have somebody deliver it through courier methods. So this is I thought I'd save this one here for last for you guys. So I want to talk about kind of moving into the products here, the microwave and the millimeter wave backhaul solutions, and knowing that there's a wide spectrum of frequency bands to use for backhaul, and really just kind of focusing today on the 6 through the 80 gigahertz frequency bands, and not really focusing on the 5.8 or the 2.4 or some of the unlicensed bands here. But I wanted to talk about the backhaul the backhaul spectrum, and we'll go through some different examples here. 80 gigahertz, it's ideal short to medium distance transmissions up to about 3 miles, 5 kilometers, if you will. There's 10 gigahertz worth of allocation at the 70-80 gigahertz frequency range, so it's ideal for multi-gigabit backhaul connections. The Oscar's example that I just showed you on the previous slide was actually done using a 2.4 gigabits per second full duplex connection or radio for the network connection here. So we can do multiple gigabits here because we've got that really wide spectrum allocation here. And the 80 gigahertz really ideal for kind of urban metro campus type applications where you're going, maybe up to 3 miles, and certainly looking at 4G cell site spacings of about 1 to 3 miles. Most of your municipalities or your education, healthcare, campus type applications certainly within that particular range here. 80 gigahertz provides real high gain antennas because of the frequency band we're operating at. And you don't need really large antennas. I think even at 80 gigahertz, the biggest antenna you get is about a 2-foot antenna. It's because of the very narrow pencil beamless. And those narrow pencil beamless also help you relative to security and interference. So it's very hard to tap into or detect that very narrow beam. You've almost got to be on top of the receiving antenna there, and because of that narrow beam width, it really cuts down on side lobe interference there. 80 gigahertz here in the U.S. is lightly licensed, so you get a nationwide license, and Bridgewave has a nationwide license, and we can add to it with the particular application. But in most cases, a lot of service provider customers, large enterprise customers have their own nationwide license, and it's only $75 to add a link to that nationwide license, and it's good for 10 years. In the UK, it's 50 pounds a year. In Mexico, it's actually 80 gigahertz is licensed free by Cofitel. So that's the 80 gigahertz backhaul spectrum, and kind of wanted to talk about some trends here on the 80 gigahertz front. Back about 5 years ago, 80 gigahertz solutions on the market were gigabit capacity. They used very low order modulation, ASK, 2-level DPSK, BFSK. There was very limited functionality to it on the Ethernet side, and we're seeing mostly enterprise adopters. So the volumes went very low on the 80 gigahertz front. Fast forwarding 5 years to 2014, now we're seeing products with data rates of up to 2.5 gigabits per second, higher order modulation, moving up to 64 QAM, 256 QAM, trying to get more spectrally efficient, adding products that are adding carrier Ethernet features, QoS, VLAN, SyncE, Ethernet OAM, Q&Q, things like that. And we're seeing carriers adopting it on a much more global basis. We showed the example earlier of Clearwire here in the U.S. Using 80 gigahertz links. We're seeing examples in Western Europe, certainly Eastern Europe and Russia, and the Middle East of folks using 80 gigahertz for operator and mobile backhaul. But I'd like to also bring to the table here that there is no free lunch. And in 80 gigahertz, where you've got 10 gigahertz worth of spectrum availability, the rush to put in spectrally efficient radios has applications in certain areas and in certain markets, but not in others. And you really need to choose the solution that fits the application and the market that you're in here. As spectral efficiency increases, many of us know what happens with the link budget. The link budget decreases. And we have a chart here that kind of shows how we move from, say, two-level modulation up to, say, 256 state modulation, 256 QAM modulation, and the effect that has on the overall distance that the link can traverse. Because at the higher order modulations, 64, 256 QAM, you've got to consider things like power back off on the transmit side and reduced signal-to-noise ratio on receiver for receiver sensitivity. And that has an effect on how far that 80 gigahertz link can traverse. And it's really no different than the principles at the lower microwave frequencies too, where you're looking at 23 gigahertz or 18 gigahertz or 6 gigahertz with those phenomena. A two-level modulated radio here, and what I've done is kind of charted this across the United States, looking at the different colors you see represent the different range zones within the United States, with the blue being the least amount of rain. This would be in your desert areas. Yellow would be along the west coast of the U.S., and green would be along the east coast and the middle part of the U.S., and then red along the southern part, the Floridas, the Alabamas, and then the Gulf Coast areas here in the U.S. And so as we look at, for example, a BPSK modulated signal versus a 256 QAM modulated signal, for that same gigabit traffic, you will see almost a 50% decrease in distance because of that. And certainly here in the U.S., we're not encumbered by the FCC for tight spectral efficiency as we are in some other areas where the ETSI standards say I've got to fit a gigabit in a 250 megahertz channel. So if you're not encumbered by those requirements, then you should be able to use the solution that gives you the maximum distance or the maximum availability, if you want to look at it in terms of availability too. So what I'd like to just share with you is our new FlexPort GigE radio. And it operates in the 70, 80 gigahertz frequency band with very high system gain. And we do that by just limiting it to BPSK modulation. It gives us that, as you saw in the chart prior, it gives us the ability to do that maximum distance or maximum availability. It starts off at 250 megabits, so if you don't need the full gigabit today, you can software upgrade to a gigabit. And there's also 2 gigabits that we can do, and I'll show you in that, and I'll talk about that with the picture here at the bottom of the page here. The FlexPort GigE has got a built-in 3-port GigE switch. Does jumbo frames, low latency on the order of about 30 microseconds at the full GigE rates. And it also has things like QoS, VLAN, Q&Q ring protection. It has one copper port that also doubles as the PoE port, as well as has got 2 pluggable SFPs that support either single mode, multi-mode, or fiber connections there to the radio. It provides carrier Ethernet functionality with synchronous Ethernet or 1588 timing, as well as Ethernet OEM for the network management. As it also does SNMP web interface for the in the enterprise space. It's powered by either power over Ethernet, or it can be powered directly through a 48-volt source. A low consumption on the order of about 35 watts. And it's got the ability to do 256 AES encryption that's FIPS 197 certified. So for those applications where you're looking for extra security, maybe your government entity or in healthcare space looking for HIPAA compliance, you can enable the 256 AES encryption to provide that encryption over the air. It's an all-outdoor design, so no indoor device needed. Fiber and power or Cat5 with a PoE directly to the radio from the indoor equipment. And the acronym here, UHA, ultra high availability here. This example on the right is an installation that we actually just did earlier this month at the U.S. Patent Trade Office in the DC area. Looking, you see here, we have dual FlexPort GHz radios. We've got an orthogonal mode transducer or an ONT sandwiched in between the two, and providing 2 gigabits connectivity over the air to the remote location. Okay. Let's take a look at the 60 gigahertz and see how they differ from the 80 gigahertz spectrum. 60 gigahertz, because of the oxygen absorption, is really limited our distance to about 1 mile at the most. And 60 gigahertz was used and still used in satellite-to-satellite communications in space. Because there's no oxygen in space, you can actually traverse much further distances at 60 gigahertz. But back in 2001, the FCC opened up the 60 gig spectrum here in the U.S., and they made it unlicensed. So that's very similar to what you might have with an ISM band or a uniband radio. You take it out of the box, you can go ahead and turn it on and operate it straight away without going to the FCC for license. It's also unlicensed in Canada, unlicensed in the UK, a couple other examples of where the 60 gigahertz products are. But the 60 gigahertz products ideal for campus WAN connectivity, where you're only shooting maybe a half a mile or just down the block, and not having to traverse very far with the radio. Got again multi-gigabit spectrum allocations. So at that 60 gigahertz, you can go from 57 to 64 gigahertz, so 7 gigahertz worth of spectrum allocation, again giving us the ability to do multi-gigabit transports. And just as with 80 gigahertz, you've got those very small, high-gain antennas, very narrow beam width that again help you with the interference immunity and as well as security. So just a couple examples here of the 60 gigahertz products that Bridgewave has. Our GE60 operates at 4 gigabit Ethernet speeds, giving you 1,000 megabits full duplex connectivity. The distance is about 1 kilometer. The AR60 and the AR60 AES, that particular product is unique in that it provides you with a gigabit connection, and then if an anomaly such as rain appears in the path, we can throttle that speed down to 100 megabits and maintain that link connection between point A and point B. And then when the anomaly subsides, we can ratchet it back up to gigabit speeds, about 1.2 kilometers. Typical distance there. Our FE60U, fast Ethernet, 60 gigahertz upgradable, so it has a base rate of 100 megabits per second, and with the software key, you can actually upgrade it to AR mode, which gives you the ability to do GigE and the throttling back to FE when needed. And then there's finally a 2-foot version for extended range application. So in the image you see on the left there is the GE60 radio going on the pole when they were doing the installation down in Dallas for the Dallas Police Department Video Surveillance Backhaul Network. And over on the right here, the National Bank of Abu Dhabi out in the Middle East has used these 60 gigahertz radios to provide that high capacity, secure banking type connectivity that you need for the finance industry. Okay. On the lower frequencies, the 6 to 38 gigahertz spectrum here, good frequency band to use for long-range transmission, or good sets of frequency band to use for long-range transmissions up to about 30 miles. In the lower part of the bands, there are 6 to 11 gigahertz typically used in rural and metro backbones. We've got a product, our EtherFlex product, that provides 300 plus megabits connectivity for those longer type applications. And then when you get into the shorter range, the metro and the urban spur routes, we have products. Our EtherFlex and our FlexPort microwave can provide either 300 megabits or 1,000 megabits, and I'll talk about each here in a second. And the antennas can be anywhere between, say, 1 foot at the higher frequencies, up to 10 to even 12 foot in diameter at the lower frequencies. And then they're fully licensed in the U.S. and Canada, as many of you are aware of. on our FlexPort microwave, we developed that a while back to provide ultra-high capacity at the microwave frequencies. So this particular radio here can operates in the 18 or the 23 gigahertz band. We've got a 24 gigahertz variant that we can look at too. But this radio provides full duplex 1 gigabit speeds for backhaul connections, for extended range backhaul connections there. We can do it by, and we do it by bonding channels. So we can do a 150 megahertz channel, 250 megahertz channels, or 350 megahertz channels to get you that gigabit per second speed here. It's got a built-in 5-port GigE switch, 1 copper port, and 4 SFP ports, again for SFPs for multi-mode, single mode, or fiber connections. Web-based NMS, and also supports SNMP. This product has the FIPS 197 certified 256 AES encryption, and it's an all-outdoor design. I thought this image here was appropriate for the webinar today. Over the last 2 weeks, many of you might be aware of the Little League World Series in Williamsport, Pennsylvania. Lycoming County, which is where Williamsport's located, has been using the FlexPort microwave here. The Department of Public Safety providing government network connectivity. What we've done in this particular application is we've paired 2 of the FlexPort microwaves together using a coupler to provide 2 gigabits full duplex over the link. And again, just thought it was appropriate on the timing with the Little League World Series just wrapping up last Sunday here. Our EtherFlex product, a fairly new product to Bridgewave. It provides it's an all-outdoor IP radio, operates in the 6 to 38 gigahertz spectrum, and do it here in the U.S. 611, 18, 23, 24 and 38 gigahertz. Bandwidth's available up to 50 megahertz bandwidth for North American flavors. We also have flavors that are used outside the U.S., 6, 7, 8 gigahertz, 11, 13, 15, 18, 23, 26, 32, and 38 gigahertz. And those bandwidths are available from anywhere between 7 and 56 megahertz. And over 300 megabits capacity, depending on the flavor, if it's a North American version or what we call an ETSI version with the wider channel bandwidth, 314 megs or 364 megs. One unique thing about the EtherFlex radio is that we actually start off at 100 megabits versus other all-outdoor microwave products that'll start off at 10 megabits or 20, 25 megabits and require you to have capacity keys to upgrade. With the EtherFlex radio, you get 100 megabits out of the box, and there's only 1 key to unlock it to its full capacity there. It has hitless adaptive modulation, where we can go from 256 QAM all the way down to 4 QAM. Again, to compensate for some anomalies in the path, whether it's rain fade, and then ratchet it back up to the highest speed there once the anomaly subsides. It's powered over PoE. PoE injectors are included with the kit for EtherFlex, and the PoE injectors also have built-in surge protection. So when you buy the EtherFlex radio or using EtherFlex radio, the surge protection is built into the radio. It's also built into the PoE injector, so no need for additional lightning protection there. It's got 2 10100, 1000 base T interfaces, along with the Ethernet switch there. It supports QoS and VLAN and 9700 byte jumbo frames. Again, built-in web management and SNMP V2 or V3 management. So I think just to kind of wrap it up here on why Bridgewave, we look at our millimeter wave products, we look at some of our microwave products with the highest link budget. When you look at the link budgets, you're looking at longer distances or applications maybe using smaller antennas. And that's important to also consider when you're looking at the total cost of the solution is not just the radio price, but the ancillary pieces that go along with the radios to provide that network connection. So when you've got a radio that's got high system gain, you can afford to use smaller antennas. The smaller antennas are much less costly to purchase, to transport, to install, and even to lease on towers or rooftops where landlords are looking to lease, charge lease rates based on the size of the antennas there. It's all outdoor design, very easy to use, PoE feed, single cable in most cases to the radio, and web-based interface. On the Ethernet interfaces, you look at the FlexPort GUHA, the FlexPort Microwave, EtherFlex, all built-in GigE switches, and they provide those carrier Ethernet services. Really, the simplicity of having a single SKU microwave, for example, you order an EtherFlex today, and it's a single SKU as opposed to having to order high band, low band, all my accessory piece parts, or if I just want to order a GE60, it comes with everything. You don't have to worry about all the different piece parts there. And then reliability with Bridgewave. As John mentioned at the beginning of the webinar here, over 20,000 microwave links installed, so 40,000 units installed in over 60 countries worldwide. Our FlexPort microwave and our EtherFlex products built on the REMIC ODU as Bridgewave as part of REMIC now. We've got over 750,000 of these microwave units installed worldwide through many OEMs and operators, carriers, and the EtherFlex product is built on that foundation. REMIC and Bridgewave were ISO 9000 and 14001 certified from a reliability standpoint. So I think with that in mind, John, we'll go ahead and I'll stop talking, and we'll go ahead and take a look at some of the questions that might have come in, and answer as many as we can on the webinar today. And for the questions that we don't get to, as John mentioned, we'll go ahead and post them to the Q&A site, the Q&A section on the Tesco, on the Bridgewave portal page on Tesco.com. So back over to you, John.
Thank you, Joe. Covered a lot of information here, and we do have a few questions. Let me reinforce the notes. If you have a question, please post it on the chat feature, and I'll just read it out loud, and we'll get Joe to respond. So we'll try to get through a few questions here with the remaining time. Here, the first one, how do we expand capacity? Can we use the same radio, or do we need to get a new radio, and is that costly?
Okay, can you repeat the question? I didn't get the first part.
Okay, how do we expand capacity? Can we use the same radio, or do we need a new radio?
Okay, sure. So how can we expand capacity? So all of our radios start off at, there are a number of radios that will start off at a base capacity rate. So for example, let's take our EtherFlex radio. We just kind of talked about that one. That starts off at a rate of 100 megabits per second. And if you need more than 100 megabits per second, there's just a real simple software upgrade key that you can purchase and enable the capacity that way. If you've got a gigabit already, and you want to, for example, let's talk about the FlexPort GUHA. FlexPort GUHA starts off at a base capacity of 250 megabits, and you can software upgrade it to 500 megabits or 1,000 megabits, i.e. a gigabit full duplex. As you saw in the example there with the U.S. Patent and Trade Office there, what they did was they actually put a second radio in parallel with the first radio to provide that second 1,000 megabit connection, and they took both fibers from the radio down to a switch that supports link aggregation. So we can expand capacity by both ways. If you bought just the initial capacity of the radio, or what sometimes we refer to as the base capacity of the radio, through a simple software key, you can go ahead and unlock the radio to its maximum capacity. And you don't have to climb a tower or do anything other than just log into the web interface and put the key in to unlock the capacity. In other cases where your radio is already at maximum capacity, you'll want to add a second radio to go ahead and double it, like you saw in the example with the Patent Trade Office, also in the example with the Lycoming County DPS, and as I mentioned earlier with Clearwire, adding a second link. Hopefully that answers the question.
Great, thanks. Here's another question. What about non-line of sight antennas for rural areas? Terrain blockages on some links.
Yeah. So all of the solutions that we're providing today are line of sight in the licensed microwave band. So a particular application like that, you might be looking at a 5.8 NLOS or 365 NLOS, and unfortunately don't really have anything in our portfolio to help with that scenario.
Okay, good. Next question. We need to connect our building to a fiber backbone that's about 4 to 5 miles away for about 300 to 400 megabits. Can we use your GigE product?
Sure. Our FlexPort microwave would be an ideal solution for that. If you're about 4 or 5 miles away, we'd certainly take a look at 18 gigahertz to be able to do that. And that would give you the ability to have a gigabit. If you don't have the ability or if there's not enough spectrum to be able to do a gigabit, we can certainly do it in one channel. Our EtherFlex product that operates at 11 gigahertz and 18 gigahertz also has the ability to transport, multiple 100 megabits, 300 megabits, that distance there. So it would certainly work with, with your Tesco representative who can run some link calculations and put together a solution that would fit your needs there.
Very good, thanks. If anyone has any other questions, please just shoot us a chat message. Otherwise, Joe, it looks like that's about it for interest from the audience, and I want to thank you and thank the audience for your participation today. And with that, we can wrap it up.
Okay, well, John, thank you again. I wanted to first thank Tesco for the opportunity for Bridgewave to present to everyone today. We're certainly glad to have had the time to do that. Tesco's, all the products that I've presented today on the webinar are certainly available through Tesco, and you can work with your Tesco representative, or you can look at the Bridgewave site too, and we can certainly between Tesco's sales engineers and our sales engineers, we're happy to answer any questions or provide more information on a path study where you might have an application for these products. But thank you all very much for your time today. I know it's everybody's all busy, and thank you for taking time out of your busy day to join us on the webinar. And John, I'll turn it back over to you.
And with that, we'll wrap it up. Thank you all for your time, and we will post a recording of this webinar on the Bridgewave portal page on Tesco.com, and we can let you know when it's available, or just check within the next several days. Thanks again, and have a great day.